Alright, it's Niaki. It's Niaki Osteozone. So today we are going to revise the November 2017 chemistry paper, the paper 2 from the Zimsec exam board. So this is all-level chemistry, and if you're doing Zimsec, you need to pay attention to these instructions to the candidates. So for section A, we are required to answer all the questions, and then for section B, we are only required to answer any 3 questions, right? So if you're not doing Zimsec, you need only to pay attention to data, because the stoichiometry for Zimsec is still the stoichiometry for Cambridge. So what matters is data, right? So section A number 1 says Fig 1.1 shows an experiment that was used to demonstrate diffusion, right? So diffusion is defined as the movement of particles from region of high concentration to region of low concentration. So we are moving down a concentration gradient from the region where our particles are highly concentrated to the region where the particles are low in concentration, right? So diffusion, it is a passive process, meaning to say it doesn't require the use of energy, right? So diffusion, it is a passive process. Are we together, guys? So you need to understand that. And what else? Also, you should be able to define the term osmosis. Osmosis, the movement of water molecules from the region of high concentration to the region of low concentration through a partially permeable membrane. So for diffusion, for osmosis, it's through a partially permeable membrane or a semi-permeable membrane. Are we together? And then for active uptake, we are moving from the region of low concentration to the region of high concentration. So it's a vice versa here, right? And then it's an active process, meaning to say we are using energy in the form of ATP, adenosine triphosphate. So this is the biological importance of these processes: active uptake, the movement of particles from the region of low concentration to the region of high concentration, and also it is against a concentration gradient. So here it was down a concentration gradient, but here it's against, because we are moving from low to high, right? So it's against a concentration gradient. All right. So define the term diffusion. We have already done that. And then here we are given concentrated ammonia and hydrochloric acid, and then we are told that we're going to have the white fumes here, right? So we have done this experiment, this kind of question in our topic of discussions, right? So we want to explain it once again. So if you haven't checked on our playlist, you need to do so for the topic of dissections. We are going to have a lot of topical series, so always remember to subscribe so that you'll be notified whenever we post, right? So the question says, explain why the white fumes were formed at the center of the glass tube. Why were they formed at the center? No, they are not supposed to be at the center, right? They are not supposed to be at the center, because we have what we call the Say-Graham's law of diffusion. So the Say-Graham's law of diffusion says that the rate of diffusion, is inversely proportional to mass, the molecular mass. So here we are having ammonia. So ammonia is NH3, and then we are having hydrogen chloride or hydrochloric acid. So the mass here for ammonia is 14 plus 3, right, to give us 17. And then here is 1 plus 35.5 to give us 36.5. So meaning to say this one is lighter, and then this one is heavier, right? This one is heavier, and then this one is lighter, right? So this one will diffuse faster compared to this one. Why? Because it is heavier. So the Graham's law of diffusion says the rate of diffusion is inversely proportional to mass. If you are having lighter particles, if you are having lower molecular masses, it simply means to say the rate of diffusion is higher. So this means to say ammonia is going to travel a faster distance. That's why it is here. So here is not the center of this glass tube, right? And then this hydrochloric acid has got a high mass of 36.5, so it will diffuse slower. That's why we are having the reaction close to the end where we are having hydrochloric acid, right? So we have factors which governs the rate of diffusion. We have mass, we have temperature, and then we have concentration. So temperature is directly proportional to the rate of diffusion, and then concentration also directly proportional to the rate of diffusion. Are we together? So here the fumes are not formed at the center. Why? Because of the Say-Graham's law of diffusion, which explains the effect of molecular mass on the rate of diffusion, right? And then we proceed to the next part, which says write a balanced equation for the reaction which produces the white fumes. So we're going to have ammonia plus hydrochloric acid to give ammonium ammonium chloride, and this equation is balanced, right? And then the other equation says, name the method that can be used to obtain pure water from seawater. So to obtain pure water from seawater, we are going to use the method of distillation. Distillation, right? So we are going to use simple distillation in this one, right? And then so you should be able to differentiate simple distillation, fractional distillation, and steam distillation. So we have simple, we have fractional, and then we have steam distillation. You should be able to differentiate these types of distillation, right? And then we have number 1b, which says to separate amino acid in the mixture. So we are going to use chromatograph. So chromatograph, you are separating based on their solubilities in a medium, right? And then for distillation, we are separating using their difference in boiling point, right? So explain why foodstuffs should be pure. Foodstuffs should be pure to avoid contamination by harmful substance which can result in infectious diseases, right? So this is to prevent infectious diseases, right? And then describe and explain how pure a liquid can be identified. So to identify a pure liquid, we can identify it by measuring its boiling point. A pure liquid should have a sharp and a constant boiling point, right? So we can use its boiling point. A pure liquid should have a sharp and constant boiling point. Are we together? And then we can now proceed to the next part. So the next equation says Fig 2.1 shows the bonding in ammonium nitrate, right? So the valence shells are the only one which are shown here, right? So we are having this ammonium ion, right? So this is dative bonding. You must take note of that, right? And then this is the nitrate ion. So we have an electron from the system. So here we are having an error here, right? We are having an error here. So we have this nitrate ion, right? This nitrate ion. So we are having nitrogen. So let me highlight for you using the valence shells. So we are having nitrogen here, right? Is the central atom, and then we have oxygen there, and then oxygen here. So this negative sign indicates that one of the oxygen atom is coming to the electron with already an electron. Is coming to the bonding with already an electron. Meaning to say, so this is the electronic configuration for oxygen. So one is gained an extra electron from the system. So it is in this electronic configuration 2,7. So we indicate that electron from the system with a star, with a triangle, I mean. Right? So we are going to have a single bond here, right? So we are going to have a single bond, right? And then we proceed to write the other shells, right? So the electrons from oxygen 1, 2, 3, 4, 5, 6, and then this one from the system 7, and then this one from nitrogen. Are we together? And we are going to have the other bonds normal, like shown this diagram, right? So this one is a dative bond whereby all the electrons are coming from nitrogen, right? So we say this one is the electronic configuration for oxygen. It needs to gain 2 electrons. So this one is attained its stability by gaining the 2 electrons from nitrogen. And then here we are having a double bond, right? So the structure of this ion, the nitrate ion, is N, and we are having nitrogen to oxygen double bond, and then this dative bond, and then we are having this single bond from the electron from the system, right? So this is the correct bonding in nitrogen, right? So you must fill this space, right? And then label on the diagram a double bond. So this one is the double bond, right? This one is the double bond. We're having 4 electrons, right? And then write the formula of ammonium nitrate. So it's N, right? And then define the term valence. So valence is defined as the combining power of an element, determined by the number of electrons it can lose, gain, or share to form chemical bonds, right? So this one means the combining power of an element determined by the number of electrons it can lose, gain, or share to form chemical bonds. Right? And we can now proceed to the next part, which says name the type of bonding shown between nitrogen and oxygen. So this one, between nitrogen and oxygen, we are having covalent bonding. And then between ammonium ion and nitrate ion, we are having ionic bonding, right? So here we are having additive bonding. So once additive bond is formed, it is identical and similar to a covalent bond, right? And then we now move on to the next question. So the next question says state any three physical properties of ammonium nitrate. So ammonium nitrate is an ionic compound, so you are simply being examined to give the properties of ionic compounds. So they have high melting point and high boiling point. High melting, high boiling point, soluble in water, and it is hygroscopic. So it is hygroscopic, meaning to say it absorbs moisture from the air, right? Hygroscopic, meaning to say it absorbs moisture from the air. So absorbs moisture from the air, right? And what else? It forms white crystalline solids. It is brittle. It forms white crystalline solids, right? And then we now move on to the next part. So number 3 says Fig 3.1 shows the electrolysis of concentrated sodium chloride. So this is the electrolysis of concentrated sodium chloride, the electrolysis of brine, right? So label on the diagram the anode. So the anode, it is connected to the positive terminal. So this one is the anode for the electrolytic cell, right? For the electrolytic cell, you must take note of that. We have two types of cell. We have electric cells, and then like the dry cell, the lead acid accumulator, which converts potential energy into chemical, potential into electrical, and then these are electrolytic cells. They convert electrical into chemical, right? So you must take note of these differences. So the anode is connected to the positive terminal of the battery, and then the cathode to the negative terminal of the battery, right? And then state the observations are made at the cathode. So at the cathode, we're simply going to have the reduction. So let us start by dissecting the whole process. We have the cations, we have the anions. So the ions in present, the cations, we are having sodium ion, and then we are having the protons, and then here we are having the chloride, and then here we are having the hydroxide ion, right? So we have what you call the effect of concentration. So we are going to discharge this chloride ion because it is highly concentrated, and then here we are only going to discharge this proton. Why? Because this sodium ion is much stable compared to this proton. So you must take note of the difference. That's why we are having the effect of concentration. So we said for the discharging of ions, we have the preferential discharge, we have the concentration, and then we have the type of electrode used. So here, that's when we are explaining the effect of concentration. And then the type of electrode, we mainly explain it when using copper 2 sulfate, using graphite, and using copper electrodes. And then other electrolytic processes, we explain using the preferential discharging of ions, using the reactivity series, right? So at the cathode, you are going to have the reduction of the protons to give hydrogen gas to here, and then we are going to observe the bubbles of hydrogen gas, the bubbles of a gas, which is hydrogen, right? And then describe and explain what happens when blue litmus paper is placed at the anode. So at the anode, we are going to have the chloride ion oxidized to chlorine gas plus electron. So we are going to have a production of chlorine gas. So the litmus paper is bleached, and also it turns from blue to red, and also bleached, right? So this is what happens to the litmus at the anode, right? And then explain why red litmus paper turns blue when it is placed near the cathode. So near the cathode, we are having so we are discharging this, right, and then this, right? So in the solution, we are going to be left with these two, sodium ion and the hydroxide ion. So these two can combine to form sodium hydroxide, which is basic, right? So this will turn the red litmus paper blue, right? Sodium hydroxide. So you must take note of that. And then we go on to the next question, which says define the term mole, right? Define the term mole and the term concentration. So a mole is defined as the amount of substance, which contains exactly 6.02 times 10 to the 23 amount of particles. So this is the Avogadro's number, right? Are we together? And then our concentration is defined as the amount of solute dissolved per given solution. So our concentration is defined, it is the amount of solute dissolved in a given volume, right? So this is the definition for concentration, and this one for mole, right? And then we move to the next part. So the next question says a mass of 20 grams of nitric acid was dissolved in 200 cubic centimeters of distilled water, and we are required to calculate the concentration, right? So we have the mass of nitric acid, so we can simply calculate the number of moles. So N is equal to mass over mR, and then we have another equation, N is equal to CV. So we want C. So C is equal to N over V. So we can calculate the number of moles using this equation, and then we can proceed, right? So N, the mass, 20 grams, right? 20 grams divided by the mR. So mR for nitric acid, we are adding 1 plus 14 plus 16 by 3. So we go straight to our calculator, and we are going to have 63. So to divide this, we are going to have the number of moles being equal to 0.3175 moles, right? And then to calculate the concentration, we are now saying C is equal to N over V. So our N 0.3175, and then our volume is 200 cubic centimeters. So to convert this to cubic decimeters, we are simply going to say to divide by 1000, right? So it's going to be 0.2 cubic decimeters, 0.2 cubic decimeters, and then here we are having moles, and we are going to punch this straight to our calculator, and we are going to have 1.59 moles per cubic decimeter. So this is the concentration, right? And we can now move to the next part, which is number 4. So number 4 says fizz drinks are made by dissolving carbon dioxide under pressure and tightly closing the bottle. So the reactions that occur are as shown. So we have reaction 1 and then reaction 2. So this is the first reaction, and then this is the second reaction. State the meaning of this symbol. So this symbol means to say it is a reversible reaction, meaning to say it proceeds in either direction, right? And then deduce and explain the effect of carbon dioxide on the pH of the drink. The effect of carbon dioxide on the pH of the drink. So carbon dioxide lowers the pH. So the effect, so we are deducing the effect, it lowers the pH. Why? Because it is an acidic oxide. So oxides of all nonmetals, they are acidic. And then those for metals, metal oxides are basic, right? So you must take note of that, right? So it lowers the pH, right? So when it dissolves in water, it is going to form this carbonic acid. So carbonic acid will then liberate the protons. It dissociates to form the protons, making the solution acidic, right? So this is the effect of carbon dioxide on the pH of the drinks, right? And then we move on to the next equation. So the next equation, number 4, says nitrogen can be produced from ammonia salts as shown. We can produce nitrogen from ammonium salts as shown, right? So we are having ammonium chloride and calcium hydroxide, right? So we are going to heat gently, and then we are having calcium chloride here, and then we are having the gas wool, and then we are having a hard glass test tube, and then copper oxide here, copper 2 oxide here, and then we are going to have nitrogen obtained here by the downward displacement of water. So ammonium chloride reacts with calcium hydroxide to produce ammonia. So we are going to write the equation, right? So the equation it's ammonium chloride plus calcium hydroxide, and then this is going to have calcium chloride plus ammonia plus water, right? plus water. So to balance this equation, we simply need to have a 2 here and a 2 there, and we can have a 2 here, and it is now balanced, right? And then state the raw calcium chloride. So calcium chloride, it is used as a drying agent to remove moisture from the nitrogen gas. So it is used as a drying agent, right? So the next question says state the change in the oxidation state of nitrogen. So we are moving from ammonia to nitrogen gas, right? To nitrogen gas, right? So we are going to have, so this reaction will produce ammonia, right? So ammonia will then react with copper 2 oxide to produce copper and nitrogen gas, right? So this is the equation you need to know. So we are moving, so the oxidation state of nitrogen in ammonia, so it's NH3. So you're going to have X and then plus 1 here. So it's X plus 1 by 3 to give us 0. So X plus 3 is equal to 0. X is equal to minus 3. So oxidation state is changing from minus 3 to 0, meaning to say it is going under oxidation. There's an increment in the oxidation state from minus 3 to 0, right? And then give one industrial use of nitrogen. So nitrogen can be used in the manufacturing, so it's industrial. So we can use it in the other process in the manufacturing of ammonia, right? And then the next equation says write a balanced equation for the reaction that occurs when we mix ammonium chloride and calcium hydroxide heated. So this is the equation, right? And then the other question says between copper 2 oxide and ammonia. So for copper 2 oxide and ammonia is copper plus ammonia to give copper metal plus nitrogen gas plus water. And to balance this equation, we need to have a 3 here and a 3 there, and we can have a 2 here and then a 3 here. So this equation is now balanced, right? And we can now proceed to the next part, which is number 5. So number 5 says Fig 5.1 shows the structure of an organic compound A. So this is the organic compound. So it is a carboxylic acid because of this, our functional group. And then name the compound. So we are having 1, 2, 3. So we are having 3 carbon atom, meaning to say it is propanoic acid, right? So it is propanoic acid, right? And then the next question says give the structural formula of the alcohol that is oxidized to give this compound. So we are having propanol. So it's C, and then OH. And then we can add the hydrogen, right? It's same as that. Are we together? And then we can go on to the next question, which says name the reagent needed to convert alcohol to A. Which one is our A? Alright, so we are going to have oxidation. So we are going to have acidified potassium dichromate, or we can have acidified potassium permanganate, right? And then next question says name the type of the reaction that occurs when a compound A reacts with our sodium carbon. Name the type. So we are having the reaction between a carbonate and an acid. So this is a neutralization reaction, right? It is a neutralization reaction. So neutralization can be between a base and an acid, and also a base and a carbonate, right? So this one can also be called in acid carbonate reaction, right? Acid carbonate reaction, right? And then we move on to the next part, which says write a balanced equation for the reaction, right? So we are having propanoic acid. So propanoic acid, right? So it's C2. So it's 1, 2. So it's C2. Then H 1, 2, 3, 4, 5. So it's H5. And then the functional group plus sodium carbonate. So we are simply going to produce sodium propanoate. So it's C2H5COO, and then the sodium metal plus carbon dioxide, and then plus water. And then to balance this equation, we are going to have 2 moles here and then 2 moles there, and the equation is balanced. So these are the products. Right? These are the products for the reaction, and it is balanced, right? And then we go on to the next equation. So the next equation says compound A is an important ingredient in animal feeds, right? Suggest why compound A is suitable for this. So it is used because it prevents the growth of bacteria. It inhibits the growth of bacteria. Bacteria inhibits the growth of bacteria, and also prevents mouth growth, the fungal infections, right? It prevents mouth growth, right? And then we move on to the next question. So we are on section B, right?